Beep, 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 beep. Okay, up we're recording. We are. So, what we're doing today, we are doing the last of our reteach assignments. We don't really need to reteach this one, but I was doing the other ones, and it's Friday. Let's do an easy one that we don't have to think about too much. We're just going to reteach. So what we're doing today, and actually let me pull it up on the board, is we're doing percent composition. And what percent composition is, well, first off, before we get to the complete percent composition, what is a percentage? Like when I give you a percent, what am I telling you? Can anybody voice that into words?
Like part of a whole?
Yeah, part of a whole. So like if I say 50%, you know that that's half of the total overall whole. So it gives me two things. It gives me the part that I'm actually talking about, and then the overall whole group that part is a part of in a way. And so an example that I was going to do is classmen. We've got sophomores, we've got juniors, we've got seniors. I also thought about doing shirt color, but there's a lot of different shirt colors, and it maybe get a little subjective. Like I know you could do black and white, and then you could do like basic colors like red, green, blue, which is what I was thinking. But where does like a yellow sweater fall in the red, green, blue? And you know, what if you got gray with some other colors there? Like, how's that going to fall in? And so it just got a little bit more complicated. We don't spend too much time on it. So let's just do sophomores, juniors, and seniors, and let's look at the percentages. And so we already identified that when we do a percent, it's a part of a whole. It's telling you how much that part is of the total overall whole. And you can see when we get to the actual chemistry part, that is what our formula is asking us for. We're going to do elements, and we'll get to this in a second. When we do the elements, it's all about the weight. When I do sophomores, juniors, and seniors, if I was really going to make this like chemistry, I would ask you all for your weight, and we would do this all by weight. Which is not appropriate or important, so we're going to skip that step because y'all don't need to know how much I weigh, and I don't need to know how much y'all weigh. Not a big deal. But remember that when we do the elements, you do need to grab your periodic table and do it by weight. It's not a count of the elements. The weight is more important. So, but when we do this, we take the individual that we're looking for. So whether you're looking for sophomores, juniors, or seniors, your individual little group needs to go on top. You do the total on the bottom. So remember, when we do a percent, we're getting how much of that individual group is part of the total group. So you want the total group on bottom. And then to make anything a percent, we need to times 100. And just a little example of that, what is 2 divided by 4? Like mathematically, what is 2 divided by 4? 0.5. Yeah, it's 0.5. Like, I guess philosophically, what is 2/4? I don't know if it's philosophically. It's a half, right? 2/4 is a half. If I have 2 out of 4, that's a half. So what percentage is that going to be? 50%. So to turn this 0.5 into 50%, you have to multiply by 100. And that's what this times 100 is at the end. Doing just the division will get you the decimal. Multiplying it by 100 times 100, 100, is equal to 50. And now you're going to have 50%. So that's what that times 100 does at the end, is moves your decimal twice and turns your decimal into a percentage of your overall total. And so that's what we're going to do here. We're going to take the number of individuals in each grade, and we're going to divide it by the total number. What's our total number of people in this class? Maybe not here today, but including the online people. 21, because 8 plus 12 is 20, plus another 1 is 21. So our total is 21, and we're going to divide each of these over 21 times 100, and we're going to get our percentages. So the best way to do this, especially if you're not really sure whether they're going to ask you for one individual or maybe all three, is just go ahead and set up all three, because these problems are really easy, and it shouldn't take you very long to set them up or do the math. So I know my total's 21. For sophomores, I have 8 over 21 times 100. For juniors, I have 12 over 21 times 100. And for the senior, I have 1 over 21 times 100. So we just do the math on these very, very quickly with our calculator, which is right behind me. 8 divided by 21 times 100 is 38.09. We'll leave it there. Sometimes your rounding will be a little bit off, but it's not too bad. 12 over 21 is 57.14. You multiply by 100 there. And then what's the last one? 1 over 21 is 4.76. Now, if I've done this right, depending on my rounding, sometimes the rounding can throw it off a little bit. But I have 3 pieces of a whole, and I didn't leave anybody out because there are no freshmen in this class. So what should my percentages add up to? 100%. Yeah, 100% is the total. And so if I've done everything right, all 3 of these will add up to 100%, and I'm sure they do, or close. It might be like 99.99%, which is fine. If it's 100.01%, maybe I'll round it a little liberally. Wait, I'm multiplying instead of adding there. Add this together, add that together, 4.76. And I got 99.99, which is perfectly fine. 99.99%. And Sapling will be perfectly happy with that. And so these are going to be really easy questions today in a way. You just have to remember, when you get the mass of your single element, you're going to, hey, I didn't tell you to start yet. We got another example. Close the combo. You're going to get the mass of the single element divided by the mass of the total chemical. All the elements added together, just like we added all of the classes together to get our total 21 students. And then you're going to do that. So one thing to remember, make sure you're doing it by mass. It's all about the weight of the elements and not just a count of how many elements you have. The count is somewhat important, but it doesn't really matter for chemistry. So percent composition, it's the mass of that single element divided by the mass of the whole chemical times 100. They have 3 steps here. These are pretty self-explanatory, but I'll go over them. Step 1, you got to know the formula. If they don't give you the formula, you do have to figure it out. Good news is Sapling will 99% of the time give you that formula. Step 2, determine the mass of each element. You got to get them from the periodic table. And even if they're not asking you for the other elements, you have to find the mass for each individual element because you need to add them up to get the whole compound. So remember that. You want each one individually, and then you want the whole thing together. And then step 3, plug it all into the equation, divide the individual over the total, multiply by 100, and that should get you your answer. Here's an example problem. Find the percent composition of each element. So here's the key here. They're not giving you just one of these chemicals. They want you to do all of them. And Sapling will have a couple questions that ask you to do all of them. So make sure you're writing this stuff down so you don't have to go back and redo it for each single element. And what's the chemical they give us? Calcium and chlorine and calcium chloride. So that's our chemical there, calcium chloride. Unlike most of the problems on the actual Sapling, they didn't give us a formula for this. So just to show you how we would get to that, calcium is in what column on your periodic table? Yeah, it's in the second column, so it will be a +2. It will lose those 2 electrons, and it will be a +2. Chlorine or chloride will be a -1 because that's 7 out of 8. It only needs 1 more electron. So a +2 and a -1, you do the cross and drop, and you will end up with 2 chlorines and 1 calcium. So they kind of show you that here. Your formula is CaCl2. So now, let's do this real quick together on the board, and then, and only then, you can start the assignment. So, our formula is CaCl2. I have 1 calcium, 2 chlorines. How much does calcium weigh? 40.078, and that's off the periodic table. How much does the chlorine weigh? 35.45. And how many chlorines do I have? Yeah, so I want to go ahead and double that because I have 2 chlorines. That's going to be 70.9. And now, what's the total for both of these? Somebody add these together, or we can do it in our head. What's 7 plus 4? Yes, CACL2. So 11 with a 0 here, and then our decimals are going to be 0.978. Correct me if I'm wrong, but that's what you get when you add these together. And if you're not good at head math, it's okay. Use a calculator. I don't mind calculators. So these are our weights. I have my weight for calcium. I have my weight for chlorine. I have my weight for 2 chlorines, which is more important. And then I have the weight for the total CaCl2. Now I have everything I need to plug these in. And they didn't ask about one chemical specifically. They want both of them. So I need to do both of them. I need to set it up in 2 problems. So I'm going to have calcium first, 40.078 divided by 110.978 times 100. And then I'm going to do the same thing. But here's the thing. If I have 2 chlorines, when I plug it into this equation, I want to use the weight for both chlorines. If I use the weight for only one of them, when I get to my N percentages, it's not going to add up to 100%. And the chlorine one's going to be wrong. If I have 2 chlorines, use the weight for 2 chlorines, because that's specifically the mass of that element. I have 2 atoms of that element, but it's the same element. So I'm going to use the total one. So it's going to be 70.9 over 110.978 times 100. Who's got their calculator ready? Will you do the top one for me, please? And who else has a calculator? Nobody else in the whole class. Only one person got a calculator. Yes, thank you. We do the bottom one, 70.9 divided by 110.978 times 100. Huh? Yeah, 978. What'd you get?
I got 36.113.
36.113. We'll leave that last decimal there. 63.88. Cool. And actually, we can just get rid of that 3. And so if you add these together, your percentages, you're going to get 99.99%, which is perfect. Just a little rounding kept us from being at exactly 100. But this is it. How much does this chemical weigh in calcium? It's about 36% calcium. How much does it weigh in chlorine? It's about 63% chlorine. So the weights can change these percentages a lot more than you think they can. So that's it. 7 does the exact same thing, and I will leave this up for y'all. Take your time. If you have any questions at all, please ask me. But that's the formula up there on the board, and you're just going to follow through with it with the weights from the periodic table. So compared to what we were doing yesterday and what we'll do next week, should be fairly easy. Oh, I've got a video recording. For those of y'all that are online, if you have questions, please visit my help section of my website. No, just email me and I'll get back to you with some help. So thank you and have a nice 3-day weekend.